much of mass is there in a unit volume? Okay, like if I were to say like there's a 1 meter cube of volume, okay, and I need to find out that in that one cubic meter of volume, how much of mass can fit. That basically defines the density. Getting it now? So in the case of air we get to see that air molecules are in continuous motion. They are always moving here and there. Yet we can't see that, but the air molecules are free to move from here to there, right? While the water molecules, they are also free to move from here to there, but as compared to air, their movement is somewhat restricted, isn't it? Yes. Yeah, please do participate in the discussion.
Yes, sir.
Okay, now, so that's why we get to see that since they cannot freely move here and there as much as the air molecules, so they will be restricted to a certain volume only. Thereby, in a unit volume, say 1 cubic meter of volume, more number of water molecules will be there as compared to the air. That's why it is more denser. Now back to the topic which I was about to discuss here. Like when air, when light rays will enter into the water, it will start to bend. It will start to bend in this manner. Look over here. Say this is a water body and this is a light ray falling on it. So light ray will actually bend in the water. Look over, that is the light ray that is high bend. So here it was entering from a lighter density medium to a heavier density medium. Thereby light rays were bending over here. Getting it now? Is that clear or not? There's no need to go so deep into the topic. Just remember this thing that whenever light rays will enter from a lesser denser medium, that is from air, to a more denser medium, that is to a liquid, or it could be any other medium also, so light rays will bend. Getting it now? So
Yes, sir.
so what is this? This is basically incident ray. And can I draw a normal here? Yes,
Yes, sir.
I can draw a normal over here. So I get to see that this light ray actually bends towards the normal.
Sir, do we call it refracted ray or reflected ray?
Refracted ray. That is called as refracted ray.
Okay, sir.
Actually. Refracted ray. So then again, when this light ray will be exiting this water body, for example, if it were to exit this water body, then again we can draw a normal over here, can't I? I can draw a normal over here as well. So now it will be emerging out of the water. Getting it now? It will be emerging out of the water. So look over here. Now the light ray is away from the normal. It has now bended away from the normal. Sundus Swaiger Chakrika, is the topic being clear, getting clear to you guys or not? These are the actual fundamental things you need to
So can you
understand first.
please explain?
Yeah, sure.
Sir, but then I have a doubt.
Yes.
Sir, if it's a water body, like how can the light pass through it? Because like
Look, just
light,
consider.
I mean, a water body is like never ending, right? It has like a
Yeah,
fixed path,
not
in the sense like
specifically
fixed base.
yeah, I understand that. Not specifically a water body like a lake or ocean. Just consider that you have got a glass slab in which water is filled. You have got a closed cuboidal glass slab in which water is filled. You can assume it to be like this. Okay, and it is filled with water, for example. Now it's
Okay.
better, right now.
Yes, sir.
So here you get to see that whenever light rays will be entering this glass slab consisting of water, then light rays, you get to see that it is actually bending towards this normal. See, this is the normal, and the light rays are bending toward it, right? And now here, the light ray is exiting this medium, It is coming out of from here. So if I were to draw normal over here, can't I just observe that it is actually bending away from the normal? Look here, that was the pathway. this was the pathway of the light inside this medium. Now, as soon as it has exited the medium, now it is moving away from the normal. Is that clear? Is that clear or not? Please do
Sir,
let
can
me
you
know.
explain once again?
Yeah, sure. Look over here. Look, this was the incident ray, and when it entered this medium, it actually bended towards the normal. Can't you see? Just it is like bending towards the normal. Huh? We can observe that now. Now,
Yes, sir.
then, continuing further, we get to see that when it exits this medium, look over here. This was the passage, this was the pathway of the light inside the medium. Now, when it has exited the medium, it is actually bending away from this normal, moving away from the normal. Is this much clear or not? Please do let me
Like it's moving like in the
know.
like
Hmm.
after that, like it will move in the straight path or in like the normal, or no, it will
After,
bend more
no, after that, it
after.
will continue to
Sir,
move in
it's
the straight
clear.
path. After that, it will continue to move in the straight manner then, because now
Like in
it is
that
back
medium,
in the air. Mhm.
so in like that medium, it will be like bending, and like when it will come out, it will be normal.
Exactly, exactly. That is what basically happens. Okay, now. Now let's go back to the topic which we are discussing over here. Now look here, look closely over here. That this light ray is entering into the water droplets over here. Okay, so each tiny water droplets that is there in the atmosphere after rainfall or during the rainfall, they are suspended air particles, water droplet particles are suspended in the atmosphere. It could be during the rain or after the rainfall also. Right now, many times we get to see that we can see the rainbow after the rainfall or during the rainfall also we can see if there is presence of sunlight. Right now, now back to the topic I was about to discuss here. Now when this light ray will enter this water droplet, it will bend because it has entered from a lighter medium to a, it has entered from a lighter medium to a denser medium now,
Yes.
right? And then again it will get again reflected back from this surface. Now pay attention to here very uh, attentively that here the light ray will be reflecting now. Huh? Look over here, the light ray is reflecting. It came in this direction and then got reflected inside the medium only. Sundus, Vaiga, and Chakrika, is it making sense to you guys or not?
Yes, sir.
Yeah,
Yes, sir.
Vaiga, look over here. Now there are two light rays actually. This one is the red and this one is the violet. Okay, actually we haven't taken all the light rays. Usually we know that it is red, orange, yellow, green, blue, indigo, and violet. We have just taken red and violet light rays in order to understand it in a more simplified manner. Getting it now why we have not taken other colors here also, in order to have the simplicity in understanding it. So the light rays has also bended while the violet light rays has also bended, and then it got reflected back from the water droplet, and then again it will be exiting from the water droplet, then again there will be refraction here. Yes or not? Yes or not,
Yes,
guys?
sir.
Yeah.
So after reflecting, I don't get it. Like what they do?
Look here, light rays when it entered it got
Me
refracted
once
first.
again, I don't.
Okay, look here, let's begin it again then. Look, light rays entered into the water droplet, so here it will be refraction because the medium in which the light rays is traveling now, it has changed. Now it is traveling inside this raindrop. So now inside the raindrop it will reflect from the walls of the raindrop. Consider that it is the inner surface of the raindrop, so from here reflection will take place. So I know that light rays is actually made up of 7 rays. 7 different color rays right now. So all of the colors of the light, white light, will actually split in different manner right now. The manner in which each of the colors present in the white light will refract will be different. Suppose like this, you get to see this light one, see this light ray. It has bent it in the different manner as compared to the violet here. Both have bent it in different manner or not right now. After that, they will be reflecting from the inner surface of the raindrop, and then they will be exiting this raindrop. So here again, the medium is changing. Now it is traveling from a denser medium to a lesser denser medium, that is traveling from water to the air. So here what will happen, as moments ago I told you that when light rays exits from a water medium to a air medium, then it bends away from the normal. Didn't I told you guys that? Yes.
Yes, sir.
What about you, Paika, Chakrika? Is the
Yes,
topics
sir.
getting clear or not? Okay, if you guys don't stop answering, then I think like you guys are getting confused. Okay.
Get it, sir?
Okay. Then when
Okay.
it exits from this raindrop, then
Sir.
refraction will again take place here.
Sir.
So that is the second. Yeah, just wait a minute. So that is the
Yes, sir.
second time refraction takes place here, and as you can see, the light rays here are actually bending away from its original pathway. It has bended away. So that is how the rainbow formation takes place. Yeah, Chakrika, continue. Yeah, Chakrika, you were saying something, or Vaiga was it?
Sir,
I can't hear you properly.
I do not get the part from uh, where I mean like when it passes through the water after
Mhm.
that part. Yes, sir. I don't get after that.
After deflection, you didn't got it.
Yes, sir. Refraction.
Oh, okay, okay. Look here. The sunlight, it is simply white light. Okay. And we know that white light comprises of 7 different colors, right? 7 different lights. So each of the light rays present in the white light will be bending at different angles, right? So look over here. The angle at which the red light has bended away, it's different from the angle at which the violet light ray has bended. Is that clear? Look at the angles. No? Their angles of bending are different. Huh? This has bended in different manner. This has bended in different manner. Look over here. If I were to form a normal over here, if I were to form a normal over here, say this is a normal line, right? So look at the angle at which they are bending. This is the normal, suppose, normal line. So look over here. This is the
Yes,
angle
sir.
at which red light has bended. And this is the angle at which the violet light ray has bended. So all other light rays like the indigo, like the orange, yellow, green, blue, and indigo, they will be also bending at different angles right now. And after that, simply deflection takes place, and then again refraction takes place as it will be now exiting the medium. So general rule, we know that when a light ray will exit from a denser medium to a lesser denser medium, then it bends away. So as you can see over
So
here. Mhm.
refraction happens, right? Reflection, right?
Then refraction happens. After reflection, then again refraction takes place.
So first reflection will happen and then refraction will happen.
Look here. In the whole phenomena, first refraction will happen. When the light ray is entering the raindrop, refraction happens. And internally, inside the raindrop, reflection takes place. And then for the second time, refraction occurs. So you can understand it like this. Okay. You can understand it like this. Refraction, then reflection, and then again refraction. All right now. So after this, you get to see a band like this, a band of different colors like this. Is that clear now? Okay, now
Yes, sir.
I hope it is clear to all of you. So these are basically formed when sunlight is being scattered from raindrops into the eyes of an observer, right?
So what is the third one? Refraction, reflection, and
Refraction again.
okay.
REFRAC. Okay, actually, excuse my handwriting. Okay, now I actually write a little bit faster. That's why many times you might get confused. Sorry for that.
It's alright, sir.
Okay, so most of the raindrops are not actually spherical. Most of the ones are actually spherical, not like this one. This figure which you are getting over here, that is not actually correct, not accurate, just for depiction. Okay, now this is like looking like a teardrop here, right? But that is not how it actually looks like. Okay, and then look over here how white light splits into its components color when it passes across a prism. Okay, so whenever light rays will basically pass through a prism, then also it will split into its component color. Right now, so that is simply the component colors of the light, white light given
The,
over here.
the white light is entering or going?
White light is entering a prism over here. Look here. The phenomena we are about to discuss right now, it is called as dispersion of light. Dispersion of light. So dispersion of light basically is what? Like whenever a beam of white light is passed through a prism, it will split into its components color. And this phenomena has been called as dispersion of light. Okay. And then the band of colors is obtained, and that is called as a spectrum. Okay. So the white light that we see, it is actually made up of 7 colors right now. So
Yes, sir.
the order of colors here is has also been provided. In short, we call them as whip gear. Getting it now? That is simply whip gear. Getting it now? And in this thing over here, this rainbow formation is actually due to the same process. It is actually due to the dispersion of sunlight over here. Getting it now? So rainbow formation is due to the dispersion of sunlight. Okay. While if
We
you have any other
say
white
that,
light, there also dispersion can be seen. Yes.
sir, we could say that the drop is the glass prism.
Yes.
We
Drop
could
as a
say that,
glass prism.
yeah,
No, not necessarily we can say that, but we can say that it acts like a glass prism, but glass prism is having a different structure as compared to the raindrops. Okay, so they were the two things, although they are not same, but they actually help in the dispersion of the light. Okay, now you can actually do one activity now. You can take the Newton's disk. You can take Newton's disk. So in which you can have all the different colors like violet, indigo, blue, green, yellow, and orange. You can have a disk like this, color them into 7 different colors, like color them as violet, red, indigo, blue, green, and yellow, and then orange and red, and then uh, place it over a stick, and then roll it, and then roll it at a good speed. So then you will get to see that when it starts to move, it will appear as white in color. So thereby, using that, it was proved that yeah, white light is actually comprising of the 7 different colors, and when the 7 different light rays actually mixes in a proportion, in a correct proportion, then white light can be obtained, a white color can be obtained. Now question might come to your guys, come to you, like the thing here is, right, like can I actually obtain, just by mixing the 7 different colors, can I obtain the white color? The thing is no. Yes, I am saying that can we get the white color if we were to combine all the colors, violet, indigo, blue, green, yellow, orange, red? You can actually perform this activity at home. But the thing is that here we are talking about light rays. What are we talking about? We are talking about the light rays, not the watercolors like we have. Okay, now.
Because it is having different particles,
Exactly,
like
it is having
because of
mhm. Because the thing over here is that light is actually the white light is actually splitting into its different component rays of colors. So we are talking about rays of light, not the actual like the colors. Getting it now? Okay, just grasp me the charger of my pen. It's actually not working. I will be back in just a second. Okay. All right. Okay. So that was simply the Newton disk. If you were to rotate it, then you will get to have the white color back. All right. Okay. Any confusion so far? Yeah.
no.
So
I'm
I
audible
still
now.
have a confusion about like the spectrum.
Okay. Yeah. Go on.
Yes, sir, like about the spectrum.
Mhm. Look, a spectrum is basically what? Like we can actually obtain all these colors. The band of these colors can be obtained on a screen. And once you obtain it on a screen, then that is simply called as a spectrum. Okay, now.
Okay, sir.
So what basically happened now? In the year like 1665, Newton he discovered by his experiments that with glass prisms he did some active experiments that he passed the white light like the sunlight. Okay, so when he passed the sunlight by this prism over here, then white light actually split into 7 different colors. Okay, so Newton found out that if a beam of white light is passed through a glass prism, then the white light splits to form a band of 7 colors on a white screen. So if you were to put a white screen over here, then the band of these 7 colors can be obtained on that. Okay. So that band of 7 color which you obtain on a screen, then that is called as a spectrum. Okay. It's simply like the
Yes, sir.
name given to the image of the 7 colors that you obtain on the screen. Nothing more than. Okay now. And then if I were to place a prism in the reverse manner like this, then what will happen? Suppose you have got a black paper like this. So once the splitted band of light rays passes through this second prism, then all the light rays will combine to form white light back. Okay. So that's how we can say that yeah, sunlight is actually consisting of 7 different colors. Getting it now? Hope it is clear now. Okay.
That
Yes,
are
sir.
two glass.
Yes.
That are two glass prisms.
Will you please repeat that?
I said like they are two glass prisms so that we can form a white line again.
Mhm. Yeah, exactly. One will be helping in the dispersion of the light rays, and the second will be helping to combine the light, combining the 7 light rays back into white light. Getting it now? Okay. Yeah, that is all we need to discuss in the chapter. Okay. Anyone who is having confusion so far in the chapter, please do ask. Or if not, I will be asking few questions then. Okay. Now,
Okay.
you guys explain to me that what are the different uses of spherical mirrors we have? For what purposes spherical mirrors can be used? Yes.
Surface shading.
Can you repeat the question?
I mean, like there
Yeah.
are two types of mirrors, and like both are
Mhm,
used in like many different ways.
mhm.
So like convex mirror is used for like shading mirrors, and um also for our side view in like cars, side view
Good.
mirrors of cars and stuff.
Mm. It could be used also as a security mirrors for surveillance. As a surveillance mirror, also it can be used right now.
You want that for
So
a
you mean
telescope,
the side view
like
mirror of the
convex.
vehicle?
Mm, Vaiga, your question is that regarding the side view mirror. Please repeat that.
No, no, it's like so the side view mirrors of the
Yeah,
vehicles we could use, right?
exactly, exactly. That also uses a convex mirror in it. Okay, Sundus, you were saying something?
One said about a telescope, like we use convex mirror.
Mm-hmm. Right, that is also correct. Okay, now. Mm. Okay, like there's a thing called like spy mirror is also there. One-way mirror. Huh? You know which mirror is used as a spy mirror? Hmm? Spy mirrors
Con
are what? Hmm? Do you guys know what is a spy mirror? SPY. Spy mirror. Anyone who has any idea regarding the spy mirror, what does it basically mean? Yes,
I
Chakrika, you.
think it is the back mirror.
Hmm. Like usually spy mirrors are what? No, the person sitting on the another side can actually see. Okay, now.
Yeah,
So
so it is actually used like in, they are considered as back mirrors, right?
they are not considered
Uh,
as a back mirror. I'm not sure about that. But simply the thing about a spy mirror is that now, usually it is it is has been like found at several places, like in the changing rooms.
So,
People here.
sir, is it like the one in the jails? Because like the prisoners talk from the other side, and like their visitors like
Mhm.
talk from the other side. They can only see each other, but like they
Okay,
cannot
okay.
actually hear what they're saying. Is it like that?
Exactly, exactly. Look here. Whenever prisoners are there in the interrogation room now, so people there's a mirror installed there, and people on sitting on the other side can actually see their activities. Okay, what they are doing. Okay, so the people are not basically aware that yeah, on the other side the people can actually see me, see my activities. Also, spy mirrors are have been found. Okay, in the different shopping complexes, in the different shopping malls, also in the changing rooms. So how to actually spot one? Okay, because there are so many
so
scams
like
people do. Hmm?
the school in which, like in the principal office, it is connected to a library, like which contains a spy mirror. We can see what can the principal do, but the
Mhm.
principal cannot see like what we are doing in the library.
Okay, okay, okay. Look, okay. So I will be now telling like how do you actually spot a spy mirror. Look, in order to spot whether a mirror is a spy mirror or not, you need to touch the mirror with your fingertip. Touch the mirror with your fingertip. And if there is not a gap between your fingertip and the reflection, it's probably a spy mirror. That is a two-way mirror. Getting it now? Like you have got the mirror, you have got the mirror, touch the mirror with your fingertip like this. Okay. And if there is no gap between your fingertip and the reflection of your fingertip, usually whenever you touch your fingertip, the tip of your finger on a piece of plane mirror, there will be a gap between the image formed and between your fingertip. Are you guys able to relate what I'm trying to say over here?
Yes, sir.
There's a plane mirror like this, and if someone were to put his or hand like this, usually there will be a gap. There will be a gap in the image that is formed over here. But in the case of this spy mirror, there will be no gap between the fingertip and the image form over there. So in that manner, probably we can conclude that yeah, that is actually a spy mirror, or simply we can say that yeah, it is a two-way mirror. Getting it now? So it is being used by the people basically to like in the people who are in the police custody, or to have a watch over the criminals during the time of interrogation, or usually shopping complexes. There also people have been the administration, the people have been caught using that. Okay, actually it's unethical to use that there right now. Okay then, so that is all we needed to discuss in the chapter. Okay, now give me a moment. I will be getting the anxiety exercises in a moment, and then we will be covering the anxiety
Okay.
questions. Okay. Meanwhile, you guys recollect what we discussed in the chapter regarding the different properties of images formed by the concave and convex mirror. I will be asking that in a moment. Okay. Now,
Sir, what was the question?
my
Like
question.
which kind?
Uh,
Like you said,
re-
have something, right?
yeah, I'm saying recollect whatever we discussed about the images formed by the concave and convex mirror. What are the properties of the images? I will be asking that
Okay.
in a okay. Before that, let me get the anxiety questions. By the way, guys, in order to get the full body image, what was the size of the mirror we require? A question we have discussed
Like
many
What
times.
what
So
size?
3 meter.
Now, my question is not simple. Simply, the thing here is that in order to get the full body image, what size of the mirror do we require?
the same size, sir.
So a small mirror.
No, sir, like
No,
half of
no,
our size mirror.
Uh, yeah,
exactly,
like half of our
exactly,
size. Yeah.
exactly. Half of the size of the person. At least half of the size of the person. It should not be, it could be more than the size height of the person, but at least it has to be half the size of the person. Okay, you'll be able to see my screen in just a moment now. Yeah, see the questions over here. Before that, first, uh, you guys answer me. What are the properties of the images formed by a concave mirror? Yes.
Sir, who
Oh,
is it to?
let me assign the question. Chakrika, starting from you. Name at least two properties of the concave mirror. What are the
Yes, sir.
images, properties,
So they
etc.?
can be virtual and real.
Mhm.
They can also be upright and inverted.
Upright and inverted.
Inverted.
Okay, okay. Or virtual and real. It can be both.
Sir, I also said that one.
Yeah,
So
good.
and also
That was the
magnified,
first
right?
one I said, sir.
Hmm. Good. Right. So you say that it could be virtual and it could be
Real.
real also. Correct. Then it could
Yes.
be inverted or
Inverted
erect
and
also.
upright. Yes,
Exactly.
sir.
In could be inverted or it could be erect as well. Upright. That is correct. And we get to see that usually it could be having different sizes of the image can be seen. Like, but different positions you will get to see that you could have the image of the same size as that of the object. It could be larger than the object also. Getting it? And it could be having a size smaller than that of the object as well. Right now. Okay, now Vaiga, you tell me about the different properties of the images formed by a convex mirror, not lens, mirror.
Like mirror, sir.
Yeah.
Properties.
Yeah, properties of the image formed by convex mirror. Okay, if you want to answer about the concave mirror, concave lens, you can
Okay.
answer that one. You can switch to that one. The following question will be forwarded to Sundus then. Or if you want, you can continue with the same question.
Okay, so like in the concave mirror, it is the mirror that curves in the reflecting surface. And if object is close to the mirror, image formed is virtual, upright, and magnified. Otherwise, the image is formed is real. And in convex mirror, it is a mirror that curves out the reflecting surface, and
Okay.
image formed is virtual, upright, and diminished.
Diminished, usually smaller than that of the object. Good.
Yes, sir.
Okay, now Sundus, you tell me about the concave lens. What are the uses, or what are the sorry, not the uses, what are the properties of the image formed by the concave lens? Yeah.
Like what? The? I didn't get the question.
What is the image, what is the property of the images formed by a concave lens?
It can be converging.
No, concave lens are not converging. They are actually diverging lens. Look, look over here. We had this diagrammatic representation now. Okay, give me a moment. Look over here. Concave lens. You can see the rays are diverging here. We call it to be a diverging lens. Now continue with the properties.
Like it is like it is thinner in the center than not like the others. They
Okay.
always like form a virtual image.
They always form a virtual image. Yeah, good. That is correct. Then the image is correct now.
Sir, and it is formed behind the mirror, right?
It is formed behind the
Formed
mirror.
behind.
Obviously, if it is virtual, it will be formed behind the mirror, behind the lens. Okay, now. And then it is
Yes, sir, I mean
also,
behind the lens.
it is also small and actually
Diminished,
far
right?
diminished or small, same thing right now.
Okay, sir.
Okay. Now, who will tell me which mirror is called as diverging mirror?
Convex mirror.
Converging mirrors.
Diverging, I see it. Convex mirror, Chikarika answer that is correct.
Concave. No, convex.
Convex, no, convex, look, you have a
Yeah.
convex mirror like this. Light rays are falling on it and then they get deflected in different direction like this. Right now, Sundus, Vaig and Chakrika. And then which mirror do we call as
Yes, sir.
the mirror? Pay attention to the word mirror. Which spherical mirror we call as a converging mirror?
Concave mirror.
Concave mirror. Okay, exactly. The light rays will be actually converging to a point. By the way, anyone who can explain to me, like, what do we call that point on which the light rays after reflection converges? That is
So
actually
the
the,
point of so the focus.
exactly, that is the focus. Getting it down. That is simply focus. Good. Okay. Now, what are the applications of concave lens? Where do we use concave lens? Like you get to see now, like there are different eye problems. People suffer from different eye problems. Someone can be having a short sightedness, someone can have be having a long sightedness. What do you mean to see say by these words, long sightedness and short sightedness? Like people can be able to see the nearby objects clearly but not able to see the objects that are far away, so thereby we say that he is having a
Yes, sir.
nearsightedness right now. So based
So
on
they
that,
are
people.
used
Mhm.
sidelines.
Yes,
So they are used in short sidelines.
short sightedness. Why they would be used in short sightedness? Look,
You said right.
look, first we actually need to know about the different problems that occurs in the human eye. Human eye actually, it acts as a lens now. Human eye, it actually acts as a lens right now. If you were to look at the structure of the human eye,
Yes, sir.
there is a lens present over here. Okay, that is actually not the lens that you have in the market. It's the
Convex.
convex lens. Very good. So convex lens and the light rays that are passing from it, it actually converges on the backside of the eye that is called as retina. Getting it now?
Yes, sir.
Okay, and the images are actually formed in the retina, but that does not occurs in the same manner as it occurs in the spherical manner, in the spherical mirrors. It's not like the light rays are combining here and there's a direct display of images over here. No, it's actually in a different manner. So there are nerves over here, nerves connected to the backside of the eye. So those nerve cells will be receiving this information, and then that information will transfer to the brain, will go to the brain, and thereby that brain will interpret it, and then you get to see the image of the object. Getting it now? So what happens now? By birth or by age, the convex lens, the eye lens, could develop some deformities in it. Either it might shrink or either it might expand. Look over here. If it shrinks, so it will become thicker, or if it expands, it will become thinner. Yes or not? Look, what happens now? If the eye lens become thicker, then the converging power becomes more. Then the converging power becomes more. So the rays of the light will be focused before the retina. Guys, are you able to relate what I'm trying to say over here? It's not actually part of the syllabus, but still, I thought let's have a discussion about
Yes,
this.
sir. Got it.
Got it now? Now, talking about this one, where the lenses has expanded, it has become thinner. So the light rays will be converged, but behind the eye. Light rays will be converging, but that will be behind the eye. So there are two conditions that develops. So that is called called namely as myopia, while another one is called as hypermetropia, in which light does not focuses on the retina properly. And both conditions can be cured using the prescription lenses or the contact lenses. Getting it now? So if the condition is mild, condition is not very severe, then it can be cured just by having the by changing the by having glass lenses. Right now, if the condition is very severe, then the surgery has to be opted. Getting it now? Now the question comes here: in order to cure these two problems, that is of the myopia and hypermetropia, what type of lens do we need? Yes, look here. In order to fix this myopia, we will be
Con-
using concave lens. Who said that? Yeah, we will be using.
Sight or convex.
Yeah, very good. So you will be using concave lens in order to cure the myopia, and in order to cure the hypermetropia, you will be using convex lens. Now, why is it so? Because convex lens actually helps to, it actually converges the light rays. Right now, convex lens actually converges the light rays, isn't it? Moments ago, we saw here that concave lens are actually diverging lens. Right now, they will be actually diverging rays. Right, while the convex lens they actually converges. So in the first one or in the second one, in which case you will be using this convex lens, in for this problem or for this problem? Guys, here, look here. The focus is behind the eye. We need to bring it back on the retina now, where the image is supposed to be used. So that's why you'll be using convex mirror here, because this person is actually suffering from hypermetropia, where the focus is behind the eye, where the focus is behind the eye. Sundu, Swaiga, and Chakrika, please do tell me if you guys are able to relate with it or not. If not, I will leave the topic then, because although it's not part of your syllabus.
Yes, sir.
Yes, sir, I can't.
Like of the focus, so that we have to give convex lens.
Okay, Vaiga, what about you? Can't hear you
Yes,
properly.
sir. I told.
Look here, let me just cover it for a minute again. Look here, what basically happens, this is the person who's suffering from a hypermetropia. That is the eye of this person, of the person suffering from hypermetropia. So where the light rays actually converges behind the eye. So convergence should actually take place in this retina now. That is the eye of the normal eye. It is right now. So convex lens, we know that it is actually converging lens, right? So using the convex lens, what will happen? The focusing power of the eye lens will be cured. Now it will be focusing on the retina now. So thereby, convex lens are prescribed for persons suffering from hypermetropia. Guys, are you getting it now? Chakrika, is it clear to you now?
No, sir.
No. Look, basically what happens now? What do we know about the property of convex lens? Like, is it a diverging or converging lens? First, do tell me that
Sir,
thing.
it's a converging lens. I mean,
Converging,
yeah,
right?
converging lens.
Converging lens, right? What is the type of lens we have got in our eye? That is also a convex lens.
Yes,
That
sir.
is right now. So here, what has happened? Now, the person who is suffering from hypermetropia, the converging power of the eye lens has become weaker. It has become weaker. Thereby, it is not converging the light is on the retina, but at a more distance. Over here, the convergence is taking place behind the eye. Getting it now? That's why, in order to improve its converging power, you will be a person is prescribed convex lens, because convex lens are
Okay,
convex
sir.
lens. Thereby, it will be converged on the retina. Then, so that is how these two problems can be cured. So that's it for
Yes,
today,
I
guys.
get it now.
All right now. So that's it for today. I hope you guys will be able to cover the exercise part. Okay. If any difficulty, do let me know in the next class. Okay, and
Yes,
then
sir.
we'll be beginning with the new chapter in the next class. Then, by the way, which chapter you guys